In this video, we introduce summary queries and look at some examples of how to create those queries. The basic premise is that there is too much data. Data is constantly being generated by websites, by devices, by your car, by the Internet of Things. There's just too much data to read through all of it and have any hope of understanding it. Therefore, we need to summarize that data somehow into useful bits of information. Remember that the purpose of a database is to put things in so they can be retrieved to create useful information. It is not simply to put things in and then walk away. We need to have the end purpose in mind. We need to think, why are we putting things into this database? How will they be extracted? And what will the use be of that information that is extracted? For example, eBay.com, the eBay Corporation, has 1 billion live auctions at this time. This information is from August of 2018. We couldn't possibly look through, scan, browse, or get anything useful out of reading 1 billion live auctions. If we had a report with 1 billion rows in it, we would probably throw it away and go become a farmer. It's just too much information to deal with. We need to be able to summarize that data to make useful decisions. The formal term is decision support. How many auctions were created yesterday compared with the number of auctions created a year ago? Are we trending down? Are we trending up? How much money did we make selling drones? What was the commission that eBay realized across all the drone sales? That's one number. Then we might want to know what percentage of eBay listings are drone sales. Are we seeing a drop in drone listings? Are we seeing an increase in drone listings? Do we need to have a special type of auction? Do we need to run a promotion to encourage more people to sell drones? In order to know that information, we must summarize the data. Now, I don't know if eBay stores their data in a SQL Server database. I would suspect that it's probably one of the choices that they have available to them with such a high volume of data. There aren't a lot of competitors in that space. But regardless of how it's stored, you can be sure that eBay is summarizing that information somehow. It's important for you then, as a database administrator, a database designer, a database manager, database user, to understand the principles of summarizing data and to be able to apply those principles to whatever database your employer or your customer happens to use. Because you probably won't be working for eBay, but you will almost certainly be working for a company that has data and that desperately needs a way to summarize that data and to use that data to provide useful information for making decisions. We will look at a few ways to summarize data. We have some new keywords that were introduced in your reading. We're interested in grouping data together. Once we've grouped it together using the group by clause, we can perform summary operations like count how many rows are in the group. We can sum numeric values. We can compute averages of numeric values. And we can filter out groups using the having keyword. Once you get the hang of this, then you'll be able to write queries that process thousands or hundreds of thousands or millions of rows and produce useful information that can be understood by human beings. Here's a basic query. We're answering the question, how many stores are there in the Pop-Tarts database? If you're not already connected, you should stop the video. You should open the VPN and you should log in using the Pop-Tarts credentials. Those are on Blackboard. They will not be repeated here for security reasons. Log in and we can create some very simple queries to do aggregation. In this case, I just wrote one line of SQL. Select count star from T Kroger store. That gives me the number of rows in that table. I can flip over to SSMS. I've already entered the use command to tell SSMS which database I want to apply my queries to. That's not really part of the query that we're writing, but it's something that we do out of habit at this point. We don't want SSMS to apply our query to another database and we would get confusing results or no results. Select count star from T Kroger store. 44. The slide says 43, but we've added a row since the slides were written. And to verify that, let's look at the Kroger store table by simply right-clicking on the table, select top 1,000 rows, and in the lower right-hand corner we see that there are 44 rows in that table. This query then counts all the rows, that's what the star means, and returns a number. We could think about this in different ways. Why can't you just look at the last primary key and that will tell you how many rows are in the table, correct? Because every time a row is added, the primary key increments by 1 since we are using the auto increment data type. If we look at the columns in the table, there's the primary key Kroger store ID. We can see that it's an integer. We need to drill down a little more. Open design view. Select the primary key, expand the properties, and we can see that it is defined as the identity and the increment is 1, meaning every time we add a row to this table, that primary key is incremented by 1. Theoretically then, and it's not a good theory, is that every time we look at the last primary key, it should tell us how many rows are in that table because it simply increments by 1. But what we don't realize, or what we're acting like we don't realize, is that the ID fields may be deleted. The rows may be deleted, and there may not be numbers that start from 1 proceeding incrementally without missing any values in between. You can see that the lowest number is 1022. That means that 1,021 rows were in this table and have since been deleted for whatever reason. If we go to the bottom and look at the last primary key value, it's 1080, meaning the next row that we add would be 1081, which is completely different than the number of rows that are physically in the table at this time. The upshot then is you cannot look at the last value of the primary key. You cannot look at that auto increment value to see how many rows are in the table. That does not work. But this does work. We can always use the count star. That's our first aggregate keyword that we can use in SQL. We can select the count of something. In this case, I don't care what I'm counting as long as I count every row in the table, and that's why I put the star in there. Looking a little deeper into our query, we did not provide an alias. And the output of the query, the column name is listed as no column name in parentheses, which is a pretty bad column name. We definitely want to add a useful column heading under all circumstances. We do not want to stop where it says no column name. That's just not friendly at all. And now when we run this, we have a nice friendly column heading, which someone who comes after us, someone who wants to use this query, can look at that and say, hey, I know what that is. That's the number of stores. And if they want to know more, they can always open the query and look at the design, or they can look at the documentation that I'm sure you've written for that query, or they can ask someone else. But that's a start. That's a valiant, fair attempt to provide a good descriptive column heading. It's a bad idea just to leave it as no column name and walk away. Not a good professional way to create this query. Think about who your audience is. Who will be using this query? It's probably not you, or it's probably you and others. We rarely work alone anymore. We usually do work that will be consumed into other work by other people, potentially around the world. You may be working with people in other countries on your project. Collaboration is a huge deal these days because projects are much too big for one person to effectively manage and deal with. Therefore, that column heading will be viewed by people from different cultures, different backgrounds, different expectations, different understandings, and it is your responsibility to make a reasonable attempt at naming things in a reasonable way. You may get it wrong, you may have to come back and rename it later, you may end up answering a lot of questions that you hadn't considered, but you have to make an attempt to communicate with your audience. We've added the alias. As noted on the slide, sometimes we put spaces in the alias, sometimes we don't. You can see that here in the slide, I did not include spaces, count of stores. But when I did the example in SSMS, I did include space. I did include spaces, count of stores with spaces. This is easier to read, I guess, if you're not a computer person. But if you are a computer person, if you've written SQL, if you've written any kind of software at all, you hopefully recognize that the name on the slide is camel cased. We capitalize the first letter of each word, and we do not put in spaces or underscores between words. And your brain will adapt to that. If you haven't done anything like this, your brain will adapt to naming things like this. And you will also get along better at work because this is the way that most people name things. If you find yourself putting in spaces, you're probably going to conflict with what other people are doing. And remember, this query will be mapped into a web page or a printed report or a PDF. And whoever does that mapping will provide human readable column names. In other words, this count of stores with no spaces will almost certainly not end up on a report handed to a customer or your boss. Somebody else would be responsible for that column name in the real report. Don't feel guilty, don't feel concerned about creating a name here that must be formatted to appear on a report. Somebody else will probably be handling that. Let's look at group by. You will use group by very frequently in your summary queries. It's important to understand how it works. Thinking about the eBay example we had earlier, if we think about all the auctions that are currently open on eBay, we want to group by the type of auction. We might want to group by the ones that close in 24 hours, the ones that close in 7 days, the ones that close in 10 days. That would give us 3 groups. We could roll up all the data into 3 groups. 24 hours, 7 days, 10 days, then we could do summary studies of those three groups. And that data immediately becomes interesting to people because someone is going to want to know how many auctions are we selling that are going to close in 24 hours? How many options are we selling? How many auctions are we selling that are going to close in 7 days? And we can see a trend begin to form. We can see that perhaps you have a very, very low number of 10-day auctions and a very, very high number of 7-day auctions simply by doing the grouping. And then we can decide that perhaps 10-day auctions aren't a good idea. Perhaps there aren't enough people using them to justify the maintenance costs that are incurred when we keep them in our database. Here is rule number 1 of grouping. It will cause you great confusion. It causes me great confusion. Print this out, put it on a post-it note on your computer screen, tattoo it on the back of your arm, carry it around with you everywhere you go. Take a screenshot of this and make it the background on your phone because it will frustrate you. When you add a group by clause to a query, then everything in the select clause must be one of these two things. It must be an aggregate expression, or it must be an expression that's in the group by. The reason for this is because it's mathematically impossible to put anything else in the select clause if you have a group by. And you will see the error that when you try to run the query, SSMS will say you can't have this in your select clause because it's not in the group by, or you can't have this in your select clause because it's not an aggregate. Think back to this slide, think back to this discussion we've had together now, and be careful to understand what that error means. Don't panic when you see an error message. SSMS will tell you what you're doing wrong. It's not always clear, it's not always the most helpful error message, but if you read it carefully, if you think about it, if you Google the error message, if you post it on Stack Overflow and ask for help, if you email me and ask for help, you can figure these things out. Let's move to the next slide, and we are going to do a group by on a foreign key. The first example is going to be silly. It's not going to have a lot of value, but then we'll build on that. Here's an example where we are grouping on a foreign key. Group by Pop-Tart ID in the intermediate table that joins stores and Pop-Tart flavors. Think back to the previous exercises that we've done. You should already have an understanding of this table and why it's important. If you need a refresher, go back and watch the video on joins. And the joins video will show you how that table, Kroger Store Pop-Tart, connects the Kroger Store table and the Pop-Tart flavor table together. Take a look at this query. We're grouping by Pop-Tart ID from the intermediate table. Remember, in the intermediate table there will be multiple records with the same Pop-Tart ID. And actually the field name is Pop-Tart flavor ID in the table, but it's similar enough that you won't have a problem. Flip over to SSMS, and let's start with a simpler example. Let's start with this. Select count star from Kroger Store Pop-Tart flavor. What do you think we're going to get? We got 90. What is that? That is the number of rows in that table. There are 90 rows joining Kroger stores with Pop-Tart flavors. Okay. If you want to verify that, certainly right-click on the table, select 1000 rows. Look at the bottom right, 90 rows. We aggregated by counting the number of rows in the table, and that's interesting, but we can even do better. Let's group this now. Let's add our group by clause. Group by Pop-Tart flavor ID. I'm correcting that field name. The answer to that question then, or the question we're answering, is how many stores sell each Pop-Tart flavor, because we're grouping by the Pop-Tart flavors. Now we're saying process this table, Kroger Star Pop-Tart flavor, process that table, and the way we process it is we're going to group all the records into groups according to Pop-Tart flavor ID. And then in each group, we're going to count how many rows are in that group. Oh, so I highlighted something, my mistake. There's what we get. Apparently there's a group of 2. There's groups of 1. Down there's a group of 4. Have we answered the question, how many stores sell each Pop-Tart flavor? Yeah, this Pop-Tart flavor is sold by 2 stores. This Pop-Tart flavor is sold by 4 stores, but it has absolutely no value. We answered the question, how many stores sell each Pop-Tart flavor, but we haven't provided much useful information. We're just going to frustrate. If you're asked this question and you need to write a view to answer this question, you need to realize that more information should be provided in the view, the query, because providing just this column of numbers is not going to help anyone. You should be able to add to this. Your intuition by now should tell you that the person asking this question is going to want to know not only how many stores sell each flavor, but what are the flavors, because as we saw, that column of numbers didn't do us a lot of good. What we can do then is group by the flavors, count the number of rows, and then join two tables together to get the flavor names. Take a close look at what we've got here then. We're selecting flavor names, we're selecting the count, and we're joining 2 tables together. At the end of the view, the query, we are adding a group by clause. Skip ahead to the next slide because it gets better. You probably have intuitively realized that to provide useful information, it should be sorted in some manner. In this case, then, we sorted by flavors in ascending alphabetical order. Now we can see that the Amish flavor, whatever that is sold by 2 stores. We can see that the birthday cake flavor is sold by 4 stores. We're starting to generate some useful information. This could be given to a marketing manager or a distribution manager, and they can see at a glance what flavors are busy, what flavors are sold in many stores, what flavors are sold in few stores. You're starting to create something that can be used by people to make decisions. Before you type this in, flip to the next slide and grab the code. That will just save you the hassle of typing it in. I'm going to paste this in. There's the query right off the slide. You should have pasted that into your instance of SSMS, and then you can run that. And there's the useful information. Now, how is this different from what we saw earlier? Well, you can see that there are different results at the bottom, and that's just because the data changed from the slide to the actual database that we're using, so don't worry about that. We also sorted by the number of stores descending. We're answering the question then, what are the stores that sell or what flavors are sold the most? So birthday cake and cheesecake are sold in 4 different stores. This is interesting or useful to someone who wants to know maybe what's not selling, or what is selling. If there are excessively large numbers at the top, there are flavors that are sold in many, many stores, and there may be some low numbers at the bottom. There are a lot of flavors that are only sold in one store. Do we want to continue to make chocolate chip cookie dough Pop-Tarts if they're only sold in one store? Maybe we do, maybe we don't. That might require some more investigation. Maybe we need to run a special, to print some coupons, to create TV commercials, to build some buzz about this wonderful flavor, but that we're only selling in one store so we can get more stores to stock that flavor. Now let's dig into the guts of this. In order to write these queries, which you will be doing, it is very crucial, if something can be very crucial, that sounds like an oxymoron, it is crucial that you understand the order of these clauses, because if you don't know the order that these clauses are processed, you will not be able to write the query. Unfortunately, the clauses are not processed from top to bottom. They don't start at the top. It doesn't do the select first, and then the join, and then the group by, and then the order by. That doesn't work. So we need to understand what happens first, what happens second, what happens third in order to make sense of what's going on in these queries. Here's how I break it down. The first thing that's done is the join. The inner join in this case creates a result set of every column of both tables. So it's a nice big result set with a lot of columns in it. And if there are a lot of rows, it may create a result set with a lot of rows as well. A nice big grid, a nice big matrix of rows and columns. Then we go to work. The second thing that happens is the group by. Before we do anything else, we group the rows together. Group by Pop-Tart flavor. That's going to collapse the rows. We're going to end up with fewer rows, but they're going to be segregated by group. The next thing we do is the aggregation. Count the number of rows in each group. And we know we're counting by Pop-Tart flavor, so since we're counting the rows in each Pop-Tart flavor, we're counting the number of stores for each Pop-Tart flavor. Then we sort it, which doesn't filter out any data but just reorders the groups, and that is right there. And then we could, if we want to, which we didn't do in the slide, is just figure out the very first one. We could shorten the result set down to one row. I can go back here then and say select top one, and then I just get birthday cake. I'm answering the question, what flavor is sold in the most stores? And this is a very, very narrow interpretation of the question. Birthday cake. That's the answer. Your intuition should tell you that whoever asks that question probably is going to want to know more information down the road. Most certainly they're going to want to know, what are those stores? Just be aware that when you provide this query, you will probably be providing additional queries to drill down. And a lot of times while you're doing the work, it's easier just to do it all at the same time and look like you're being proactive rather than waiting for the person to come back and say, well, you told me what flavor is sold in the most stores, now what are those stores? And then you'll have that answer immediately because you also wrote that query, and you'll look like a superstar. You're probably going to be asked, okay, wise guy, you told me what flavor is sold in the most stores. Now I want to know what store sells the most flavor. So we're reversing the question a little bit. Instead of the answer being a flavor, the answer is going to be a store. And again, you may want to write this query when you're asked to write the initial query. You may want to wait for them to come back and ask for more information depending on the situation that you're in. So I will leave this one to you. You should be able to modify the work we've done here to answer this question. What store sells the most flavors? You can probably realize that we need a top one. We need an inner join. And we can make a couple of basic changes to this to get the answer to that question. If you'd like to do that on your own and email it to me, I'll be happy to look at it, just to let me know that you're making an attempt to solve these problems and that you're watching my video. In the next video in this series, we will move on to the grocery store database and write more summary queries.